Imagine you're a devious art forger looking to make some quick cash by faking a painting by a famous artist and selling it to a museum, like the MFA here. For your plan to work, your fake painting can't raise any suspicion, otherwise you could be in big trouble. One way to go about this might be to think of every measurable property of a painting: its subject, its brushstrokes, its colors. Then look at all the paintings of the artist whose work you want to copy and replicate all those properties as closely as you can. That sounds like a lot of work, though. Plus, you're worried that all this math might make you forget your artistic touch.
So here's another idea. What if you hired a brilliant detective, an expert, in fact, in detecting art forgery? You could practice your craft, make the best fake you can, then show off the results to your expert painting verifier. If she can't tell you're fake from a real piece by the artist, you've succeeded.
This system is exactly how generative adversarial networks function. The words may sound scary, but GANs are a fascinating framework that computers can use to produce crazy things, including art. You might have heard of machine learning and artificial intelligence. GANs are a way to help computers get better and better at a certain task, so they're a type of machine learning.
In a GAN, you have two neural networks competing with each other. A neural network is a bit like our brain. It has a bunch of little parts, called neurons, that all connect to each other, and these neurons help it sift through a bunch of input to create an output. The neural networks in our head might see an animal, and based on all the other animals we've seen, our brain will tell us that it's a cat. To create a GAN, we take one neural net which we hope gets really good at producing something. This is the generative part. In the same way that your clever art forger brain can look at a Mary Cassatt painting, fire off some connections, and try to produce something similar, a neural network can do this too. Meanwhile, a second neural net tries to get really good at telling real things from things produced by a computer. The two compete against each other. This is the adversarial part. As the first network gets its creations judged, it's able to adapt based on what successfully tricks the second network. As the second network sees more real and fake things, it also gets better at its job and picks up on what makes something fake.
These networks go head-to-head, one the expert forger, the other an art detective. As they improve each other, eventually the forger can get insanely accurate, so accurate that we humans can't tell a fake from the real thing. This includes paintings, but it can also be videos, music, or even language. GANs are a compelling tool, so as we move into the future of tech, it's important that machine learning like this be monitored closely. GANs are already being used to produce videos of people like politicians doing or saying things that never happened and could potentially do a lot of harm. So, for anyone who goes into the field of computer science, it's important to always keep ethical responsibility in mind and use the power of GANs for good.